Now there's one more problem that we want to discuss in this course. Consider this visualization. What do we see? We see large dark areas in the south, and we see a nice distribution of dark and bright areas in the north of this country. Now the problem is this is something that a person with color vision deficiency would perceive. This is not what the data actually shows, and this is not even what the visualization shows. The original visualization is showing this. It uses a color scale that ranges from red to one side to green to the other side. And what do we see now in this map? We see the green south and the red north, which is not what we see on the left side. There are three main types of color vision deficiency, also called color blindness. And each of these types is related to a specific type of rods in your eyes, your retina. On the top we see normal vision. We have three types of rods, the ones for blue, the ones that are sensitive to green, and the others that are sensitive to red. And this gives us the full spectrum of colors that we can see with the two examples of the right. Now, in the first type of color deficiency, color vision deficiency, deuteranopia, the population, the specific person misses the rods for green. In the second time, protanopia, the person is missing the rods for red, and in tritanopia, the person is missing the rods for blue. What we can see on the right is how they would perceive the specific color. If you cannot perceive any of these colors, you're missing part of the spectrum, and your brain is making up the other colors around it. Color blindness is quite common. We have among 8% of male population suffering from any of these types of color blindness, and about 0.5% of the female population in Europeans at least. Now, the different types of color blindness are distributed differently. Deuteranopia is also called red-green weakness, is the most common among them. Now, if you consider these numbers, 8% and 0.5%, if a submitted manuscript happens to go to 3 male reviewers of Northern European descent, the chance that at least one will be colorblind is 22%, so 1 out of 5. So next time you consider your paper or your poster, keep this in mind. You can use tests to assess color blindness. If any of you is not seeing any of the numbers showing inside the circles, you are colorblind for this specific type. Now, how can you test for colorblindness? Knowing about colorblindness is obviously one element, but when you're designing a visualization, you want to be sure that it is colorblind safe. These images are made from a website, it's colorblindnes.com, which has a simulator. You can upload a map. I uploaded the one on the top left, and you can then check for different types of color deficiency. Now, each of the maps in the center, this one, and these ones, are simulating specific color vision deficiency conditions. And you can see this website has way more than I was just discussing. For example, it has included the black and white map for comparison. Now, what we can also see from this map is this color scale that this map uses is not at all too bad, because in any of these pictures we still can see the differences between these colors, and there's barely any two colors that have the same value. So how to choose a colorblind safe palette? Of course, you can always upload your visualization, and this is also recommended. But there are a set of predefined color scales that are good. For example, if you go to colorbrewer.org, it gives you a little checkbox where you can say, I want only colorblind scales, colorblind safe scales, and it will give you only those color scales that are colorblind. However, the amount of palettes that you have gets reduced when you go to categorical datasets for categorical scales, because it becomes harder to create colors that are different and perceptually different for categorical data. However, if you look at the literature, um, there are some other defined color scales. For example, the one on the top, on the bottom left, and then on the bottom right are some color scales that work well across different types of color vision deficiency. What else can you do? You can use, for example, redundancy, redundant encoding. If you use colors and you're not sure if your colors are colorblind safe or anything else, then you can use additional visual variables such as texture, for example, to enhance your color perception. So for every value that you are assigning a color, you also assign a specific texture as in this example. Now the advantage of doing this is not just to help colorblind people, but also to help reviewers, for example, who print your paper in black and white, because the color information may get lost. Texture information, as in this example, does not get lost.